Hi everyone, and welcome to my series on electric circuits. In this video, we'll be going over some basic concepts, including charge and current. So let's get started by talking about electric circuit, electric charge, and electric current. Okay, so let's define an electric circuit. In general, we are interested in the transmitting and transferring of electrical energy from one point to another point. So we need to interconnect the electrical devices with each other in order to do so. Therefore, an electric circuit is just an interconnection of those electrical devices called elements. To study electrical engineering, we have to be familiar with some concepts. These include charge, current, voltage, a few circuit elements, power, and energy, which we'll discuss over the next few videos. Next up, let's define electric charge. Electric charge is represented by the letter Q, and it is the fundamental property of particles which allows them to attract or repel each other. The like charges will repel and the opposite charges will attract. We can have negative, positive, or neutral charges, and here in these two pictures we see that when we have two negative charges, they will repel, and when we have opposite charges, like one negative and one positive, they will attract. The charges are measured in coulombs. One proton has 1.6 times 10 to the negative 19 coulombs, whereas one electron has negative 1.6 times 10 to the negative 19 coulombs. Now, let's talk about electric current. When charges, generally electrons, move in a particular direction, it generates a current. So therefore, a current is just a movement of charges. In a conducting wire, there are many free electrons that are ready to move. And once the battery is connected, the electrons will be forced to flow. Here in the DC current picture, we have current flowing from the positive terminal to the negative terminal of the battery. And in DC current, the current does not vary with time. Whereas in the AC current, we see that the current is oscillating because it varies sinusoidally with time. Now let's go on to discuss current convention. In electrical engineering, it is conventional to take the current flow to be from the positive terminal to the negative terminal of the battery. This is not what happens in real life, where the electron flows from the negative terminal to the positive terminal. However, in electrical engineering, we just take it to be the other way, from the positive to the negative. Now let's continue with defining our current. So current is defined by magnitude and direction. So if you have positive 5 amps of current flowing in this direction, to make it flow the opposite direction, we just change the positive sign to a negative sign. So here, the magnitude will be 5 amps, and the direction is defined by the positive and negative sign. Finally, we're going to talk about the relationship between current and charge. We've talked before that current is the movement of charges. However, a more mathematical definition of current is that it is the time rate of change of charge. And current is measured in amperes. So here, I represents the current and it is measured in amperes. The Q is measured in coulombs, the charge, and then T is measured in seconds. In other words, current is just the amount of charge flowing across a wire in a certain amount of time. Now, let's go on to do two examples. In our first example, we're going to calculate the amount of charge present in 4,600 electrons. We've discussed before that there are negative 1.602 times 10 to the negative 19 coulombs of charge per electron. And we have 4,600 electrons, so we need to multiply that by 4,600. The electrons will cancel, and we're left with negative 7.4 times 10 to the negative 16 coulombs. This is the amount of charge present in 4,600 electrons. Let's go on to our second example. Determine the total charge entering a terminal between t equals 1 and t equals 2 seconds if the current passing the terminal is I is equal to 3t squared minus t amperes. So we're asked to determine the total charge. And we know that time is going from t equals 1 to t equals 2. And the current is 3t squared minus t. We've discussed before that current is the time rate of change of charge. In this case, we want to find the total charge. Therefore, we have to rearrange this derivative to find that the total charge is equal to the integral of I dt. We know that I is given in the question, and the integral will be from 1 to 2. So I is 3t squared minus t dt. We can compute this integral. 3t squared, the integral of that will be t cubed. The integral of t will be t squared over 2, and we will calculate it from 1 to 2 seconds. When we plug 2 in to this expression, we have 8 minus 2. And when we plug 1 in to the expression, we have 1 minus a half. And from there, we can calculate our charge, which will be 5.5 coulombs. And that is the end of the video. Thank you for watching. If you have any questions, feel free to drop them in the comments, and I'll see you guys in my next video. Goodbye.